So hey there guys, in today's video I'm going to start a new chapter of mathematics, and it is very important for both the students of applied mathematics and advanced mathematics, or you can say core mathematics. Okay, so different schools have different name for their division of mathematics at class 10th. So but this chapter, that is your permutation and combination, it is very important chapter. Your permutation and combination. Permutations and combination, one of the most important chapter of mathematics in class 11th. Why? Because this chapter has been asked in your you can say IIT mains level, IIT mains, or you can say advanced level paper, and then it has also been asked in one of the most toughest exam of India, that is your UPSC, Union Public Service Commission examination. Okay, and in many other state examination. Okay, so I think I have to complete this chapter. I am going to provide just a basic detail of this, and then we are going to do some questions. And if you want to do some more question, then join my live classes by sending me hi on 870-754-9139. Two demos are exactly free, and then we are going to start with what this chapter. Okay, so before starting this chapter, I want to let you know some basic steps before this. Okay, so what do you mean by a term called the factorial? What is mean by that? Okay, so if we have some natural number, or you can say 3, we have to find the factorial of 3. So it is going to be the product of first natural numbers up to that number. Okay, so it is going to be 3. It is going to be factorial 3 is going to be 6. Okay, so now if we have to find the factorial of 4, then it is going to be the continued product of first natural number up to that n. It is going to be 24. Okay, so the factorial will be defined as the continued product of first n natural numbers, and is defined as n factorial is equals to, we have to start from 1, 2, 3, 4, and we have to go to n minus 1 and then n itself. Okay, so one of the question is being raised here that, sir, is the factorial of integers, or you can say negative integers, and the fraction is defined, or you can say what is the factorial of 1 by 2 factorial, or you can say minus 1 factorial? It is not defined. Okay, so you have to left with only option that your factorial is defined only for your whole numbers. Okay, only for your whole numbers, that is starting from 0, 1, 2, 3 to what, infinity. Okay, and sir, what is the meaning of the 0 factorial? Okay, so I'm going to prove it later, but I'm just assigning it the value as, the value of 0 factorial as 0 factorial is equals to 1. Okay, so just remember that your factorial is not defined for your fractions or for your negative integers. Okay, so I think I made my point here clear. So now doing some question of this, suppose you have to convert the following products into factorial, like for example, convert the following products into factorial. You have, I'm just giving 2 3 examples, so let me make you clear what do you mean by that called 6 8 dot 10. Okay, so taking 2 common from here, we have 1 dot 2 dot 3 dot 4 dot 5. Okay, so now I already told you that this is the continued product to up to 5, so it is going to be 5 factorial. Okay, so just one more thing, that 2 is going to be common from this, and then 2 is going to be common from this, 2 is going to be common from this. Most of the students make mistake by taking this common, but you have to add here 5. Why? You know that because you are going to separate 2 from first, second, third, fourth, fifth terms, and then there is a multiplication sign in this. So 2 to the power 5 into factorial 5. Okay, so it is the answer of this. And now suppose you have to find what? Third LCM of factorial 4, factorial 5, factorial 6. You know, LCM is going to be the least common multiple, or you can say where all these number are going to meet, or you can say we have to find the multiples of all these factorial number. So we know that your factorial 6 is what? 6 into 5 into 4 into 3 into 2 into 1. So we can write it as 6 into 5 into factorial 4, and then we have what? Factorial 5 is equals to 5 into 4 into 3 into 2 into 1. We can write it as 5 into factorial 4, 4 into 3 into 2 into 1. Okay, so we can write it as factorial 4. Okay, so you can clearly see that your multiple is going to be what? The greatest number, or going by the definition we know that LCM is the least common multiple where all these number are going to be meet. Okay, so this is the number. So LCM is going to be 6 into 5 into what? Factorial 4, or you can say your factorial 6, which is going to be 6 into 5 into 4 into 3 into 2. It is going to be equal to 720 is the LCM of this number. Okay, so now moving on to another concept, that some questions we are going to do, just the CRT example. Okay, so we have factorial n fourth, factorial 2, n minus 2 whole factorial is to factorial n upon factorial 4, n minus 4 whole factorial is equals to 2 is to 1, and we have to find the value of n here. Find value of n here. Okay, so let's start. As always, remember that here you have what? N minus 2 factorial. Okay, and here you are having n minus 4 factorial. Just remember that is your greatest number is going to be broken into smaller one. Okay, and n minus 2 is greater than your n minus 4. Okay, so n minus 2 is being broken into a smaller number, like for example factorial n factorial 2, n minus 3, n minus 2, n minus 4, and the process continues here. Okay, so is 2 factorial n upon factorial 4, n minus 4 factorial is equals to 2 is to 1. So I can clearly write here factorial n upon factorial 2, n minus 4 factorial, because there is going to be a continued process here. We are going to get n minus 5, n minus 6, and then so on. So I can clearly replace it by this. Okay, I think I made a point here clear. So n minus 4 factorial, and then you have n minus 3, n minus 2. We have what? Is 2. So we can what do? Just reverse this sign. Factorial 4 n minus 4 factorial upon factorial n is equals to 2 by 1. Okay, so now cancelling this, n cancel, 4 into 3 into 2 upon factorial 2, n minus 3, n minus 1 is equals to 2 is to 1. Now you can basically solve here. You are going to get a quadratic equation, and then you can basically solve it here. So I think I made my point here clear how to do these type of question. You have to basically divide this larger number into a smaller one. Okay, so now moving on to another type of examples of this question of this chapter. Okay, so let's see another example. We have to prove two inequalities. First there is a equality, and then second there is an inequality. Prove that 2n factorial upon n factorial equal to 135 dot 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 2n minus 1 to the power 2n. So we have to prove this. So taking LHS, taking this side, we can open this 2n, 2n minus 1, 2n minus 2, and then the process goes on till 1, 2, 3, 4. Okay, and upon you have what? Factorial n. So I can basically do what here? I can basically separate odd and even numbers here, separating odd and even numbers, separating odd and even integers, or you can say natural numbers. Okay, separating odd and even natural numbers here, 2, 4, 6, 8, dot dot dot, 2n minus 2, and we have what? 2n. You know why these are all going to be an even natural numbers, and then we have what? 1, and then we have 1, 3, 5, 7, dot 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 dot, 2n minus 1, okay, as your odd natural numbers. Then we have what? We are going to write factorial n here. Okay, and now what we are going to do, same process, we are going to take out 2 from here, just like I did in example here. Okay, so taking common 2 here from this side, 2, then we have 2, so we are going to get basically square here, and then 3 we are going to get cube here. So n terms we are going to get 2 to the power n as here. So 2 to the power n, 1, 2, 3, dot 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 dot, n minus 1, and then n. So the next question that we are going to prove is that it is the important question. I think it has been asked in examination CBSE many times. Okay, what does the next question state? That we have to prove that factorial n upon n minus r whole factorial r plus factorial n upon r minus 1 whole factorial equals to n plus 1 whole factorial upon r factorial n minus r plus 1 whole factorial. Okay, as I had already told you that we have to do what? We have to decompose the greatest number here. Okay, I already told you in the example that we have to decompose the greater number, and here the greater number is this, we have to decompose it, and this, and LCM is always the greater number, n minus r plus 1 whole factorial r factorial. Okay, so in decomposed form it looks like this. It contains all the numbers that are given here. Okay, in fact itself too. So we have 1, 2, 3, dot 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 dot, n minus r, n minus r plus 1, and then 1, 2, 3, dot dot dot, r minus 1, and then r. Okay, so now dividing this, clearly see what is going to happen here. Dividing this by this, you know, this is this factorial, and this is entirely r factorial. So we are only be left with this option. So multiplying this, n minus r plus 1 with factorial n, okay, plus factorial n. Now for second, we have to divide this by this, and when we are going to divide this, we are seeing that we are only be left with this option. Okay, as n minus r whole factorial is going to be this equal thing, and r minus 1 factorial is going to be this equal to, we are only left with this. So we are multiplying this by r. Okay, so now proceeding further, we are going to get, taking factorial n common from the numerator, n minus r plus 1 plus r upon n minus r plus 1 r factorial, cancelling r up, factorial n plus 1 upon n minus r plus 1 factorial r factorial. Okay, you know what is going to be this? This is going to be the n plus 1 factorial upon n minus r plus 1 whole factorial r factorial. This is going to be equal to your RHS. Okay, so I think I made my point here clear. What is the factorial and how you are going to solve some questions related to factorial. Okay, so now moving on to the another concept, that is what fundamental principle of counting. What do you mean by that called fundamental principle of counting? Now let's start the next topic. Fundamental principle of counting. Okay, so here we have two principles, or you can say we have two subcategory in this. First is your fundamental principle of multiplication, and second one is your fundamental principle of addition. What do you mean by the term called that? Suppose if there are two jobs, okay, if there are two jobs, okay, and one of them can be completed in m ways, okay, you can do the first job. If you are having two jobs, such of them, you can complete first job in any of this first way, second way, third way, dot dot dot, m way. Okay, and after completing the first job in any of these way, you have to perform the second job. Okay, in second job you can perform the second job in any of the first way, second way, third way, and in nth way. Okay, so you can perform both these jobs in succession as m into n ways. Okay, so I think I made my point here clear. You have what? You have first job, and then you have subcategorized this, or you can perform another job at first way, second way, and then nth way. So both this job can be performed in what? M into n ways. Remember, we have to perform it in succession. Okay, so now what is the fundamental principle? I'm giving you, just don't be confused. I'm just giving you an example. What do you mean by term called that? What do you mean by term called fundamental principle of addition? If you have the first job, you can perform it in m ways, okay, and you have the second job, you can perform it in n ways. Okay, they both are what? Independent jobs. Okay, and here it is what? You have to perform either of them. You have to perform either of them. Okay, so these can be performed in m plus n ways. Remember, there is a lot of confusion between the fundamental principle of addition and fundamental principle of multiplication. Okay, so I think I made my point here clear. So now moving on to another concept. As you know that in fundamental principle of multiplication, this first job is said to be performed if all its sub jobs are performed. Okay, or you can say that they are connected to the first job, but here you can say that they are independent of each other in fundamental principle of addition. So now let me give you an example. Suppose you have what? In a class, one of the easiest example, there are 10 boys and 8 girls. Okay, and you have to select, or you can say your class teacher have to select, your class teacher has to select a boy and a girl. Okay, in how many ways he can select it? In how many ways he can do the selection? Okay, So first he can do what? He have to select both these in a simultaneous way, or you can say he have to perform both the jobs in succession. Okay, you can't say that they are independent of each other. Okay, he have to perform both these job in succession, or you can say simultaneously. So first he can do what? He can select a boy, then he can select the remaining of the 8 girls. Okay, first girl, second girl, and then he can select the second boy, and then he can do what? This 8 types. First way of selecting a girl by selecting, let's suppose the teacher has selected a boy, that is your first boy, and then he can select the first girl given he has selected the first boy, or you can say he had selected the second girl given he has selected first boy, and the process continues till he select the eighth girl as he had selected the first boy. So now as he had selected the second boy, now you can select the first girl. Okay, given that he selected the, so in this way we can see here what we have: first 8 into 8 into 8, and then this is going to be 8 into 10, or you can say 80 ways. Okay, so I think I made my point here clear how you are going to perform. Now suppose he had to select a boy and a girl. Okay, and just replacing this statement, select either a boy or a girl. Okay, or a girl. So he can do what? This is going to be just different things. He can do what? He can select any of the boys in, like for example, this is the boys and this is the girl section. He can select first boy, second boy, okay, and third boy. He can do this by in 10 ways. Then he can select the first girl, second girl, and then eighth girl. So 8 ways. But he have to select either this or that. Okay, he can't perform both these jobs simultaneously. So this is the case of what? Your fundamental principle of addition. Then this is going to be equal to 10 plus 8 is equals to 18 ways. I think I made my point here clear. Okay, so this is one of the most important concept in mathematics of class 11, fundamental principle of addition and multiplication.